So thank you to the friends of VA Grade for this opportunity. I would like to take some time to share with you our experiences in using the DIM so far. But before we do that, I would like also to take some minutes to show you who NEO is, because probably not all of you is familiar with NEO and our mission in the industry. So there will be a short video and I will come back later. So after watching the video, you might now understand which challenges we had at the beginning when we started. Of course, most important was the time to market for us to win the competition. We had a very small windows of opportunity there to launch our new EV platform, and then of course because of the way we work with users, we also are committed to very fast iteration and keep our product very fresh. Nonetheless, of course, being a startup, we are also facing a lot of challenge when it comes to the investments and the money spent for development. So all these reasons brought us to the decision of investing in the DIM from VA Grade. So how did we use DIM at the very beginning? Of course, we were focusing on the vehicle dynamic development. I think you're all familiar that the starting point through Adam's car, which is a desktop simulation, very much engineering driven and very much objective if you want. But thanks then to the car real time and the DIM, after that we were able to introduce, of course, all the subjective feeling and the subjective evaluation early enough, so we could have comparison between different solutions and, of course, anticipate problems that then were normally coming out in the prototype phase if you don't use an advanced stage or an advanced validation stage in the virtual phase. So we started, of course, with the VD development, but very soon we realized that the real advantage was actually to put together more functions, and we expand the utilization of DIM into the full vehicle engineering level, so including the powertrain, the brakes, the steering, and so on, in a coordinated way so that we can enhance our final results to the users. And also very soon we engaged also our colleagues from the product definition and user department, because we started using DIM also for this level of subjective evaluation and try solutions or alternative functions that of course I cannot fully disclose, but we needed to evaluate in order to understand if they were positively received by the market in advance. So we are using then DIM so far for all the vehicle dynamics tuning, from the suspension in terms of comfort, ride and handling, the steering portion and the brake portion. When it comes to advanced studies, we are developing the new platform here, and we also started to integrate more and more hardware in the loop to get more valuable data out of the usage. Another pillar of our utilization is actually for the performance side. We have been using DIM for a couple of activities, promotional activities that we did, for example, in the Formula One circuit in Shanghai or in Nürburgring and others. And last but not least, again, is about the utilization for the user experience, where you can actually test the human reaction to certain new features or certain functions or certain decision that we will take for the future car. So if I can summarize the experience we had so far with the DIM, you can see in the bottom of this chart the timeline. I think we started in 2018. Actually, we started with DIM before, but in 2018 we have released basically the ES8, and then we follow up with the ES6 and ET7. DIM was very much utilized and used since the very beginning. What we can say is that it was very important for us to achieve the system efficiency with low cost, with good and fast results, and then of course a safe environment for certain function. This we will summarize one more time at the end, but definitely it led us to less prototype building, saving on test resources, and then of course much faster iteration between different solutions and different calibration and tunings. And as I said before, we were able to test some of our limit handling and AD in the very early stage, where there's not mature enough to run on a proper prototype, on a proper open environment. So if that was what we achieved so far, now let's have a look at the future. Obviously, you all know the future is going very fast towards the autonomous drive, and this is where we are investing now our resources on DIM to understand how we can actually use it to integrate all the components that are defining a good autonomous drive experience. We have the vehicle components, of course, we have the controllers, we need to define the scenario, the driver is in the loop, obviously, we have all the sensors, and then defining events and see how do we want to use it. Basically is really to collect all the data from an objective assessment, but also very much into the subjective assessment, because that we believe is the real key to define a good AD towards a not so exciting or not so safe AD development. Another focus point for us is also how to integrate all this available information into a more advanced and a more coordinated chassis control, when the AD technology can contribute also to the manual driving of the car. And of course, it's also a matter of integrating all this information like GPS, V2X, HD map, and so on and so forth. We are doing it in steps, of course. We are doing some basic functions. We bring more and more hill, so hardware in the loop and fusion of cameras and other hardware into the DIMM. And then last, we will have an advanced step with all the other remaining portion of this. So you can see now we are trying really to integrate everything that constitute the AD domain into the DIMM and make this interaction as smooth as possible, also from a point of view of the communications and latencies and response, input and output responses and so on. What we achieved so far, we have integrated this trinocular camera, which is now in all our products. We integrated our own ADC controller. Then, of course, everything else is built in a way that can really interact with the world simulation and the drive simulator as well. Has been tested so far on some basic functions, and of course we have the plan to go all the way to what is considered we call it the Neo autonomous drive, or NAD. So if I can summarize, I think first of all, our job with the DIMM has been definitely faster, easier and safer. We believe we have cut at least 3 to 4 months from a normal vehicle development when it comes to the full dynamic development. Of course, it's a much safer tool compared to running in proving ground. We estimated that per each model we run around 2,000 equivalent kilometer of proving ground. At the same time, this has been proven to have less risk, less cost and better time to market for us. We allow us for much quicker iteration, especially in the early stage when the platform was in development phase. And then, of course, we have verified that we had the possibility to reduce the number of prototype builds on mule builds and so on, and rent, of course, the facility renting, facility cost, estimating around 2 to 2.5 million RMB. Then platform is a tool that can be scalable and expandable. We will do more and more integration on hardware in the loop, and of course, as I said before, very much focusing on the subjective experience on the advanced functions like autonomous drive and other that we have in mind. So with this, I came to the end of the presentation. Thank you one more time to VI Grade, and thanks all of you for listening. Thank you.